Ich habe ja extra geschrieben, aber die Medien jetzt. Ja. Cool. Ja. Die sind toll, aber wir sind auch toll. Weil das waren schon viele Mühen. Aber cool. Ich bin gespannt. Jetzt noch eine Kurzsendung.
Ladies and gentlemen, I would like to welcome you all very warmly to this WBA webinar on Biocoal, the ideal drop-in substitute for steam coal. My name is Christian Rakosch. I'm president of the World Bioenergy Association, and we're very glad to run this webinar today together with the International Biomass, Torrefaction and Carbonisation Council. And I would like to very warmly welcome my colleague, the president of this association, Mr. Michael Wild, to join in the webinar. He will take over and also facilitate. He will be the first speaker. But before I give the floor to Michael, just a few comments. Firstly, this webinar will be recorded, and the webinar recording as well as the presentations will be available on the website of the World Bioenergy Association. Please have a look. We have a whole range of different subject webinars that are available on this website. You may find other events that we had in the past that might be of interest for you. So everything will be available there at the webinar site of World Bioenergy Association. And finally, if you want to ask questions, and you're very welcome to ask questions, please do so in the chat. And we will try to answer the questions right after each presentation. So with that, over to you, Michael. The floor is yours. Please introduce us to the question why biocoal is an ideal drop-in substitute for steam coal. The floor is yours. Michael, over to you.
Thank you very much, Christian. And I appreciate that you being of German tongue, spelling my name the proper way. Usually I'm used to be called Michael Wild, which I'm also used to already. But still I appreciate once it's done properly. I am wondering if my screen share works now, because I don't think you can see my screen, or can you?
Yes, we can.
You can, yes, you can. That is perfect now, so it's only here. Yeah, thank you for this introduction already. And as said, I am the president of the International Biomass, Torrefaction and Carbonisation Council, an industrial association that was established in 2012, so 14 years ago. The association was from the very beginning on established with a very industrial focus, so very different to other thermally treated activities like biochar and similar. We had always been looking into industrial applications and larger volume applications. This is also reflected by the number of members we are having and the size of the kind of members we are having. You see that by now, aside of Antarctica, we are covering all continents around the globe, and our members are fully integrated into the value chain. So we have producers, processors, we have technology suppliers, we have traders, but we have also consumers being members of the IBTC. The IBTC as such obviously doesn't touch topics under competition, but is trying to build the basis for for commodity-like trade and consumption of torrefied biomass, also of carbonized biomass. Here we are speaking about torrefied biomass, mostly about biocoal, which is produced from two processes we will introduce during this webinar to you. We are producing a lot of general information and also contribute to the market development in a form that we are working on transport regulations, we are working on standardization of products. Here is one example. We have released a terminology guidebook or handbook. It's almost like a dictionary because we understand, or we saw very often, that people really are a bit lost in all the terminology that is used around these black biomass materials. Please feel free also to download this free of charge from our website, ibtc-council.org. That's enough of the commercial for us. For today, what am I going to talk about? I'm taking the role of introducing you briefly to what is biocoal, what is it made from, which processes do exist, what for can we use it, why are we building it, and then also give you a short update on the general status quo before handing over to some of our members. They represent then their individual approach to the market and their individual success stories already. Now, what is it we are talking about? We all know coal is present, and coal is in reality made out of biomass. In many million of years, this is made. I mean, if we talk about peat, it's maybe only a couple of million years, but if you talk about lignite or subbituminous coal, we're talking about a couple of 100 millions, and anthracite takes about 400 million years. Now, the overall clue in our technologies and in our approaches, we do the same, but we do it much faster. We work in a couple of minutes. We do the full carbonization curve that usually goes through the biomass that is under pressure and temperature when it's under Earth. And we have along these processes, process chains, a couple of process names. Every time we are applying heat to the biomass. And by this, we not only eliminate the water content, but we eliminate also some of the volatiles content of the fresh and dry biomass. Now, as the first process step, we see steam explosion that makes the lowest calorific value still very high quality product. Only a small proportion of the volatiles is evaporated. Next temperature level is summarized under the term torrefaction. Here we lose already more of the volatiles and recirculate later on in the process, as I will show you. And the higher we go, in this process, we have further names: pyrolysis, carbonization, charring. This is all processes where the more of the volatile matter in the biomass is evaporated, and the more the carbon is condensed, the higher the calorific value of the product, and the higher also the value of the product for other purposes than for energy applications. Today, we are looking into the energy applications. We will have another webinar together with WBA on non-energy utilization of these materials, but here we are looking into thermal applications. So, when starting to present these processes, especially in the financial community or some other areas, I'm always asked, is this a mature technology already, or is this such a novel thing? You may remember what brought us from Bronze Age to Iron Age. 6,000 years ago, we developed charring processes, and we developed all the metallurgy out of the charring processes. So actually, there's hardly any technology or any product with such a maturity and such a long-lasting success story. However, what differentiates today's processes from previous processes? In previous processes, all the gases have just been evaporated and emitted. So that is a huge emission, a huge loss, but also a poisonous thing. So what differentiates us today from the past? What differentiates us from the past is that our installations are all completely integrated and no molecule really is wasted. we typically use all kind of biomass feedstocks. So we can use woody biomass feedstock, but we can also use grasses, straws, shell, nutshell, or whatsoever. Everything would be in an adjusted thermal process, then upgraded, and that would then lead to products that at the very end, after the torrefaction or steam explosion, are fluffy matter for storage and transportation, need to be agglomerated. We typically have a setup of a processing plant that is very similar to a standard pellet plant, where you first of all, you dry the biomass, whatever biomass it is, and then you go into a torrefaction reactor, which is the only difference to a pellet plant. So here we have a superheater or super dryer that is typically operated at probably 200 to 300 degrees C, or here we might have a unit that does some steam explosion activities that you will be introduced also then in parallel. However, out of this process, this thermal treatment process, then we have a material that need to be densified as such. Is there only one way of applying heat to biomass? No, by far not. There is many different ways. And as you can imagine, or as you can see, when you want to get your glass of water warm in your kitchen, you have also different means of applying the heat. You can have the microwave, can have a cooking pan, you can have an oven. So also here in applying heat to biomass, we have all kind of different technologies, from rotary drums, auger screws, vibrating belt. We have multiple Hertz reactors, also some batch reactors, moving bed reactors, or cycling fluidized bed reactors, and we have steam explosion with a separate line of machinery you'll be introduced to. So what is the process level we are talking here about? We are talking at the moment in decarbonization about a process that will apply to the biomass heat of about 250 to 320 degrees C. By this, evaporating roughly 30% of the input dry mass in form of syngas. This syngas is composed of carbon monoxide, of hydrogen, of some long chain molecules. And this syngas contains also energy. In a typical torrefaction or process, you would reduce your mass by about 30%, but only 15% of your original energy would end up as syngas. The best set point for a production line of torrefied material is the way when this becomes an autothermal process, meaning the syngases are then combusted in an oxidizer, and this heat is used for the torrefaction process and for the drying of the raw biomass. That would be an ideal set point, and in such set point, the mass and energy balance of a torrefaction plant is almost identical to a whitewood pellet plant. What kind of products are coming from the carbonization and torrefaction processes? And also here to clarify a little bit. We are speaking today about biocoal. Biocoal is a low devolatilization product. The calorific value is between 19 and 20 on dry basis, can go up to 23 probably also, and will have a fixed carbon of not more than 25%. The total carbon will be 60% or something like this. This product is usually the ideal drop-in fuel for drop-in substitute for steam coal. So in power plants, the power plant digests biocoal as well as it digests normal coal. But this material is also the ideal input material for all kind of gasification processes, since it is so brittle that you can grind it up to talcum-like powder very easily. So then you ease the gasification, and by this then also all the liquefaction afterwards. If we go further up this curve, as you remember from the beginning of my presentation, we will end up with biochar or biocarbon materials that are used for sequestration of carbon or for other industrial purposes, like the decarbonization and the fossilization of the metallurgical industry. As said, these products to be tradable need to be densified because otherwise they are too fluffy and too brittle and would cause a lot of hazards. There are a couple of different form factors that are traded today. One of the standard form factors are pellets, somewhere between 6 and 12 millimeters, most common 6 and 8 millimeters. But we see also piston briquettes or extrusion briquettes from 40 to even 100 millimeters diameter. We see roller briquettes, mostly for higher carbonized material, and also, especially for biochar, we see sometimes agglomerated materials. Agglomerated materials meaning snowball-like materials that are having not a very high bulk density. When we produce these products in a proper form, in these pellets or briquettes, we can reach bulk densities of about 720 to 750 kilograms per cubic meter. By this, reducing also shipping costs versus all kind of other biomasses significantly. I spoke before about the typical process setup. The typical process setup would be as is with a standard whitewood pellet plant. Sizing, drying first, then we go into the thermal treatment, and then into the densification. There is now, especially in Asia, first projects that turn it a little bit around, and they do first densification, so pelleting, and then torrefaction. Whatever the customer wants, I think the processor is willing to set up. Both have their pros and cons. We can discuss this eventually later if of interest to you. Where are we standing at the moment? This is a young industry that had a long time to wait until the first industrial projects really were implemented. We see that we have today approximately a capacity of 700,000 tons up and running. By the end of the year, that will be a little bit above 1 million. But we see that already from the projects in pipeline, so this is the green bars, and in pipeline, this is where the contracts are already either on the letter of intent stage, memorandum of understanding stage, or already signed up. Shows that we will have a growth rate that is significant, up to about 13 to 20 million tons by the end of this decade. This is just a survey from the members of the IBTC. So these numbers do not cover all the companies that are not organized in the IBTC. And I need to admit there are a couple of them not yet organized with us. If you're present, please understand this as an invitation to join us. The products will go mostly at the moment to the power generation, so the power sector, but we see that more and more of these materials are also taken up as a bio-intermediary, so really as the feedstock for further processing, like SAF production or further upgrading at a later stage, so that torrefied material, steam exploded material could be seen as the global commodity that would be used then as a feedstock for all kind of further processes, including power generation, but many more sophisticated processes that might then supply the metallurgical industry, that might be used as sequestration material, and all kind of other growing markets like anodes and further applications. Here are a couple of experiences which we had in the power industry. Started out actually in Europe, but then we had a couple of projects in North America, like Portland General Electric and OPG, Thunder Bay. There is currently also a very large project in Canada announced. Belledune power plant will be converted to thermally treated pellets and upgraded. And we see also that this is not only an effect in Europe and in North America. This is also very, very common by now already in Japan, where a lot of the coal power plants are using standard biomass for co-firing and are switching now step by step into torrefied biomass, because that simply eases their conversion process so significantly. In conclusion, and to sum up here, our products are really known to the market, and this is a 6,000-year success story of these products. We have in the last 2 decades established processes with a real optimized mass and energy balance, meaning there is minimized material and energy waste. Literally every molecule into the process is used in the process and creating some value through the process. Circular biocarbon, biocoal is absolutely the easiest and cheapest way to substitute fossil coal. And these not only in power applications, but in many other applications as well. So defossilization with biomass and with thermally treated biomass is significantly cheaper than ammonia, than hydrogen, or whatever pathway you would look into. While we have today mostly energy coal that we substitute, we are foreseeing that much more product will go into others, especially in the liquid and in the SIF market. We know from the projects that are currently implemented that if there is a sustainable feedstock secured at reasonable costs, the projects that are implemented at the moment are really offering very appealing project IRRs. And the beauty of the situation at the moment is there is not only one technology producers, there's a couple of technology providers on the market in a very healthy competition and in a very fruitful competition, and that leading to a number of different projects. Also for the consumers, the advantage that they have not to put all their eggs into one basket, but they can really diversify also their basis of supply. As said, we foresee that the whole industry in biocoal will have a compound average growth rate of somewhere between 60 and 70%. And by this will be one of the fastest industries growing at the moment. By this, I conclude, just inviting you again, address the IBTC with whatever questions or comments you would have to the sector, and please feel free to join us. We'd be very welcoming to all of you. Join us here. We are based in Vienna, but basically we are covering activities, as said, around the globe. That is, thank you very much. And in case you have any immediate questions, please then speak up, and I stop sharing my screen and see if we have in the chat some questions already. Difficult to read. Okay. Steam explosion, not the lowest, and we exceed 21 as a standard product. Yes, we will hear about this as well then. Unfortunately, we cannot use the presentation as a steam due to the misstatement on the outset. Yeah, I don't know, Richard Springs. Maybe you can explain your question. That is not very clear what you were mentioning here. How do you see the market reasonable price of biocoal and biocarbon? Basically, as an industrial association, obviously, we should not speak about prices as such and not cause collusion. But I think the overall idea for renewables is that they have to compete on a basis of the cost of the fossil fuel, their substitute, plus the avoided cost for CO2 emissions. I think this is a rule of thumb, but as said, the individual cost negotiations, they have to be taking place with the individual project developers. And there was one question about hydrothermal carbonization. I need to say, as IBTC, to date, we do not have a member with HTC in portfolio, which I consider a pity, but is as is at the moment. Then there is one more question. Can biochar biocoal be used as a substitute in coal in coke production? What quality parameters? Yeah, basically, yes, biocoal can be introduced into coke production. That is then biocarbon. So where you have almost all the volatiles released. And this will be the focus of our second webinar together with WBA in September, where we will speak about this and what these processes then apply. What technical requirements these applications would have. So please stay tuned. That we will continue in September to discuss. And is there a technical limit for this drop-in? There are a couple of projects that will convert 100% of the power plant. There is no technical limit like with whitewood pellets. With Biocoal, we have seen many plants operating 100% on the basis of Biocoal. I have to close the question session now. There are more and more questions coming in. I will try to answer them probably or have them separately answered. But would now pass on to our first speaker from Andritz, Maximilian Lehr, who is going to present us what the Andritz portfolio in thermal treatment and production of Biocoal is. Max, the floor is yours.
All right. Thank you, Michael. Good afternoon, ladies and gentlemen, and welcome to the Andritz presentation about our solutions to produce advanced solid biofuels. For all of you who have not heard about Andritz yet, just a few words about our company, what we do, who we are. We always consider ourselves as a global pioneer in delivering large-scale industrial technology solutions, mainly for four big industries: pulp and paper, metals, hydropower, and environment and energy. And yeah, I'm quite proud that we are among the top 3 players in each of these business areas. We cannot be everywhere, but we try to be as close as possible to our customers. So we have around 30,000 employees at more than 280 locations in 80 countries worldwide, as you can see here also with this map. I'm one of these Andritz employees. My name is Maximilian Lehr. I'm a technology manager at Andritz Fiber and Recycling, based in Vienna, Austria. At Andritz, I'm responsible for our steam explosion and biomass leaching technology, what I will present you now. But first of all, I would like to start a bit with the core challenge. Michael already mentioned it. The increased motivation to substitute coal has created a tremendous demand for solid biofuel. This demand is projected to reach 1 billion tons per year by 2030. Currently, just around 10% of this demand is produced. So the question is, where will the other 90% come from in the future? Fortunately, there are companies like Andritz supplying complete lines to produce advanced solid biofuels. And these advanced solid biofuels like steam explosion pellets or torrefied material can then directly be used to replace coal. And I'm proud that we as Andritz are the only company in the world offering both steam explosion and torrefaction. But the question is now, what are actually the principles behind steam explosion and torrefaction? Michael explained it already. I will try to explain it also with slightly different words. Let's have a look behind the scenes how the magic works. I want to start with torrefaction. Torrefaction is a dry process, actually a dry thermochemical process. This means lignocellulosic biomass is heated with pressurized, sorry, I'm already too fast. Biomass is heated in oxygen-free atmosphere to around 250 to 330 degrees Celsius. And that causes the hemicelluloses and part of the lignin to decompose, releasing so-called tar gas. The resulting torrefied material has improved fuel characteristics, for example, high calorific value and high fixed carbon content. Steam explosion, on the other hand, is a wet process, actually a wet mechanical, physical, thermochemical process. What does that mean? This means that the lignocellulosic biomass is heated up in a pressurized atmosphere with steam to around 200 to 215 degrees Celsius. And this leads to a partial conversion of the hemicelluloses into different degradation products like acetic acid and furfural. Lignin, on the other hand, is softened and partly melts. And all the steam which is injected into the reactor condenses inside the capillary structure of the lignocellulosic biomass. And after a certain retention time, the biomass is continuously discharged, and a quick pressure drop causes all the water inside this capillary structure to rapidly flash, to expand, and that leads to bursting of the lignocellulosic feedstock, resulting in fine powder. And the lignin is precipitated on this powder particle surface and acts as binder during pelleting. Yeah, you may have already asked yourself, why do we as Andritz actually offer both steam explosion and torrefaction, and what's the better technology? Yeah, well, unsatisfactory answer, it depends. And it really depends on many factors. As you can see here with this table, there are various differences in the product properties between steam explosion, pellets, and torrefied material. For example, the calorific value, fixed carbon content, durability, pelleting properties, and so on. To simplify it a bit, if you're just looking for a drop-in fuel for coal-fired heat and power plants, steam explosion might be the better technology, but for the steel and cement industry, on the other hand, you will need torrefied material because of the higher fixed carbon content. Unfortunately, it's not that easy. Furthermore, there are also various project or site-specific parameters that can play a role. For example, you maybe already have a steam boiler on site, do you have a demand for waste heat, and so on. So as you can imagine, for every project, there is a different, better technology. And our advantage as Andritz, since we offer both steam explosion and torrefaction, is that we are quite technology agnostic and always find the best solution for every project. And yeah, this best solution can be, for example, simply pelleting to produce white or conventional pellets, or if you want to directly replace coal, steam explosion or torrefaction to produce advanced solid biofuels. And yeah, we as Andritz also look beyond advanced solid biofuels. Steam explosion powder or torrefied material can also be used as feedstock for gasification to produce syngas. And this syngas then, as Michael also already explained, serves as platform then for various syntheses to produce biochemicals and biofuels, for example, sustainable aviation fuel. But for this webinar today, I would like to focus on advanced solid biofuels. So the question, how do these processes actually look in more detail? I'd like to start with steam explosion. Our Andritz steam explosion technology, or SteamX technology, how we call it, starts with biomass handling and preparation. In the case of woody biomass, for example, debarking and chipping. Yeah, depending on the process parameters and the process options, the chipped biomass then can also be hammer milled and optionally pre-dried before entering the SteamX core process. In this SteamX core process, the lignocellulosic biomass is converted into the steam explosion powder, as I already explained, and this powder is then pelleted to steam explosion pellets. All the vapors or waste steam are condensed, cleaned, and purified in order to close the water loop and recycle all the water. Here we work together with Sulzer Chemtech, which allows us to efficiently treat the SteamX vapors and close the water loop, and optionally also fractionate the resulting hemicellulose degradation product to utilize them as valuable biochemical byproducts, for example, furfural and acetic acid. Yeah, and the second advanced solid biofuel technology we have in our product portfolio is torrefaction. Similar to steam explosion, also here the first step is the biomass handling and preparation. Woody biomass is debarked and chipped, but does not need to be hammer milled. A key advantage of our torrefaction process is that also waste wood can be used as feedstock. And in these cases, we can deliver the entire waste wood processing line using our Andritz recycling equipment. After preparing the raw material, it is dried and then fed into our dedicated torrefaction reactor, where it is transformed into torrefied material. This torrefied material can then be further densified by briquetting or pelleting. The resulting tar gases are utilized in our dedicated combustion chamber, and the resulting hot flue gas then provides thermal energy for the torrefaction reactor and the drying. Since torrefaction usually generates more energy, more heat than it consumes, the surplus heat can be exported as hot water or steam when combining with a steam boiler. As Michael already said, torrefaction can be applied before densification, as shown here, or also after pelleting, which allows to upgrade existing white pellet plants to advanced solid biofuel lines. As indicated here with the highlighted process stages, a major advantage of Andritz is our ability to deliver complete integrated production lines. That means we can supply the key equipment for each process step, fully complemented by fully integrated control and automation system. Also, Airx is using our Andritz technology to produce advanced solid biofuels. Our pellet mill has been in operation already since 2016, continuously producing 2 tons of biocoal pellets per hour. And we are continuing to develop advanced solid biofuel densification solutions alongside with the front end, steam explosion, and torrefaction. So it clearly shows that we are eager to take on any challenge to develop the right advanced solid biofuel solution to meet the market demand. And that's actually the reason why we have focused on agricultural residues with our leaching process. I already presented the different pathways to produce solid and advanced solid biofuels from woody biomass and some annual plants. But agricultural residues can, however, not be directly used to produce solid and advanced solid biofuels because their high ash and mineral content leads to severe issues like, for example, corrosion and wear during biofuel production, like pelleting, and also slacking, fouling, and corrosion during combustion in industrial combustion systems. But with our leaching process, we can finally unlock the potential of agricultural residues by significantly reducing this high ash and mineral content. How does this work? Here you can see such a schematic layout of our leaching process. This leaching process is basically based on our well-proven pulp and paper and environment and energy equipment. Sandstones and other heavy impurities like metal pieces are separated from the biomass. And all the soluble elements, for example, potassium, sodium, and chloride, are extracted from the biomass. The resulting wastewater, or leachate, how we call it, containing all these minerals, can then be optionally treated to minimize water consumption and reduce wastewater production, and ensures or let's say aligns perfectly with all the environmental legislation. The resulting leached biomass then is of course much less corrosive and less wear intensive, which especially ensures a smoother pelleting, and of course we meet all the stringent biofuel specifications and ensure cleaner combustion. Our leaching process can of course also be combined with our technologies for biomass drying and also steam explosion and torrefaction for complete lines to transform low-value agricultural residues into high-value advanced solid biofuels. And this is not just a concept, what I present you today, it is actually reality. With Andritz key equipment in the world's first commercial scale empty fruit bunch D-Max pellet plant, which is powered by Rainbow Pellet in Malaysia. This plant consists of leaching and Steamex technology and was designed as multi-feedstock plant using or being able to use empty fruit bunches alongside with other palm oil residues as well as wood. We have successfully started up this plant just in spring this year, but please be aware this plant is just the beginning. So ladies and gentlemen, please stay tuned. But now I would like to thank you for your attention, and I'm already looking forward to your questions.
Thank you, Max. Thank you for this comprehensive presentation of yours. There are questions in the chat room. I'm afraid we cannot go through all of them now, so I ask you, Max, just to answer them bilaterally also here in the chat. But there is one or two questions that might be interesting for you to answer now publicly. Does your leaching process also reduce the silica content of the biomass?
Yes. Yes, of course. I mean, we remove basically the heavy impurities like sandstone, so that's already like a major fraction of the silica content. The silica inside the cells, for example, when we talk rice straw, is a bit more tricky, but yeah, we are, I would say, right now working on that topic, and we are developing a solution exactly for that purpose.
I think you answered in your presentation also another question that popped up here. What agri and fruit nut biomass can be used as residues in your technologies beside wood residues? I think in your presentation you gave here ample answers to this already, how flexible the processes are. So
Yes.
by this, thank you very much, Max, and I can just encourage all of the in the auditorium to address also Max directly on bilateral level if you have deeper and further questions on these. But I would now invite here to our podium Eric Haugen. Eric is the CEO of Arbaflame, one of the longest established steam explosion companies. I think I first stumbled across your products in 1999, so there's really a long legacy. Also, you have changed your name in between. But yeah, please give us an update where you're standing, what your product process looks like, and what's your plans in the future. Floor is yours, Eric.
Thank you, Michael, for the kind introductions and to WBA and IBTC for facilitating the webinar. So I'll give you a quick introduction to where we are in Arbaflame at the moment. As we have now close to about 4 years of operational experience from our first commercial plant, Arbaflame in Norway. Before that, we also had a smaller scale pilot plant. So now we would say that we're definitely up to technology readiness level of 9. And based on the long list of lessons learned we have, we are definitely come to a stage where we can scale further. So Arbaflame is our first plant in Arbaflame. We are a Norwegian company utilizing steam explosion technology. That's unlike Max and Andritz technology. It's batch based, and our core product from the process is Arbaflame, our Biocoal, which is a direct coal substitute. We also, in our process from the condensates, also produce other biochemicals, including furfural, biogas from the wastewater treatment, biomethanol, and acetone. So we actually regenerate about 1/3 of the energy in the process from byproducts. In addition, last year we got Pearl Infrastructure Capital on board, which recognized that our technology has reached a point where we can go from small scale into a scale-up mode, and we are part of their second fund. We also now got a French sister in the portfolio, FICAP in France. So altogether, we have a total capacity of about 180,000 tons yearly capacity. So just a quick highlight of the market. So the coal market is enormous, and the biocoal market is, like Michael said, not a new technology, but still the biocoal production is in the early stages and yet scaling up quickly. The addressable market is enormous, and we're not trying to replace all coal in the world, definitely not. But really to target where it makes the most sense, where you have the most difficulties to find alternative solutions, and where it's a direct drop-in substitute for coal. So basically, it's not yet a commodity market. It requires qualification, and as we are operating in a highly conservative business, we often see, based on our 35 tests at various industrial sites in large scale, that is that. From the first kind of little sample until full-scale operations, it's a long process. It's also highly important to maintain the highest standard of sustainability when it comes to sustainable forestry and certification of the feedstock being used, and also to thoroughly measure the CO2 footprint throughout the value chain. And like Michael also mentioned regarding the call it the benchmark price is typically the alternative, which is the fossil fuel cost plus the CO2 tax. And there are a lot of companies talking about sustainability, but as of today, most companies are still kind of more focused on the economical side rather than the reduction of the CO2 emissions. So, but there are still a pretty good drive for doing implementation of decarbonization of their fuel. Quickly on our process, our batch-based steam explosion process, we use sawdust in Arbaflame. And why do we use sawdust? That's because it's homogeneous and quite stable. Fine particles product. We dry it down to about 35% moisture, and we steam explode in our batch reactors. We have 4 batch reactors in Arbaflame. So we kind of pressure up to a certain level. We hold it for X number of minutes, and when we release the pressure in the reactor, that's when the magic happens, and when the biomass defiltrates and it's blown into the flash tank where we separate the gas and the biomass. The gas is being condensated and taken to our biorefinery, while the biomass is dried down to the right moisture level for pelletization and then off to market. The product itself, it's originally designed for ultra critical coal-fired power plants. So it's very fine particles. Bulk density of about 750 kilos per cubic meters, and calorific value of about 5.2. Moisture 8%. It's high on durability, and the particle size is extremely fine. So most of the use is intended for combustion as powder after milling. So we see that due to the fine particle size, the volumetric energy in the powder is extremely high, about 70% higher than conventional white pellets. And when kind of comparing against other alternatives, again, we are a drop-in replacement of coal. We're not really trying to compete with white pellets, where the investments in the required infrastructure is already made. But we have really kind of mirrored the physical properties of coal, but in a climate positive product. Looking at our track record so far from Arba1, we've had now close to 4 years of stable operation, and altogether in total we have produced around 250,000 tons of Arbacor, and we have shipped off quite a few vessels. We're now actually close to about 1 vessel per month. It's not a very big number, but at least it's a pretty good start, and we kind of reached a maturity stage where we are really confident in how to do this in big scale and to really gain some proper volumes. We have a lot of experience with testing the product over time in our conservative business. The traditional use of the product is within combustion, industrial thermal energy, basically, typically in all types of industrial boilers, CHPs, different type of kilns that requires high temperatures. Going forward, we also see really high interest within fixed carbon, where you don't utilize the energy in the pellet, only the fixed carbon. And even though we don't have a high carbon material, we are still actually delivering quite a lot of volume to the metal industry, as we have a pretty good, stable, homogeneous product with about 20% fixed carbon that we can deliver in large shipments, bulk carriers. We're also further into the pipeline, see a lot of potential within gasification, Max mentioned as well, within sustainable aviation fuel. And we're actually also qualifying our product for gasification this year, doing a 10,000 ton test. And we see that due to the particle size and the properties of the product, it's very good input to gasification process. And again, we're not trying to replace all types of coal use, but we really want to see the properties of the value chain, of the combustion setup of the industrial facility, and not just to kind of compare price per ton one-to-one with the alternatives. We have developed a solution, and we really want to kind of find the optimal use of the product. So, looking at our setup, our chain of logistics at Arba1, we have storage facility where we hold 3,500 tons of Arbaflame. At the port of Oslo, we have a 10,000 ton bulk storage. And from port of Oslo is where we do the dry bulk shipments. Typically, it's from 3 to 10,000 tons shipments. We have done quite a few tests, campaigns, full scale, different blends. We have quite a lot of experience with storage and shipping. And obviously the hydrophobic properties, the low ATEX and the lack of self-heating risk and low dust are kind of the key aspects. At the bottom of the picture, you also see an example from earlier this year where we have a customer which don't have suitable storage areas for anything actually. So it is possible to also pack, like in this case, 5,000 tons of pellets for long-term storage. Looking at the kind of the journey from the first sample being tested, there's a long process that typically takes up to 1 to 3 years. It's a quite slow time to market for the product. At least that's our experience. And naturally, the operations don't like to change too much, especially not when things are working. So the typical process is to do small scale testing, milling tests, lab qualification testing. Then move on to the trial, where the size can be from a few trucks to a big vessel, to do different blends, typically starting low, going higher, to kind of get the measurements on the emission data, the grindability, how the mix is operating in the mill, how the combustion stability is, and most importantly, the performance output of the product. Then the next step is really to see, based on the trials, how could you optimize the existing equipment, how to kind of fine-tune the parameters in the facility to get the most out of the product. Then, after going through that, that's really when you can sit down and talk about long-term offtake. And this is also kind of the main reason why we don't like to operate in the spot market through traders or intermediates, but really to find the best solutions together with the end user and the operations, because this is it's not yet the fully commoditized product, and there are a lot of tweaking that could really optimize the use of the product, and also to make sure it's a successful and safe test. On that note, we also are part of the SPP certification program. We want to ensure that all Biocoal in Europe is following the highest standards of certification and sustainability. There are examples where uncertified biomass is entering the European market, and we really want to be in the forefront of ensuring that our small and yet growing industry maintains the highest standards when it comes to sustainability. And it's no question about the compliance with the RED III requirements. And they're getting stricter, which is good. And it really is kind of contributing to getting more accurate data on the emissions, on the traceability, and really the full life cycle assessment of the product. Going forward, we now are at the stage where we are confident that we can use the lessons learned and experience we have from Arbaflame to scale up, basically using the same equipment and technology that we have today. So we don't plan to do any technology development. We see that Finland is kind of leading when it comes to providing the best assessment and factors for our next plant. We see a good availability of sawdust. We see that it's regulative-wise attractive market, and also with a lot of potential customers. So the kind of the main triggers for making the investment decision is really to have a solid long-term offtake agreement in place, and to have full confidence in the feedstock supply base. So we are actively working on maturing the case, and hope to be able to progress that fast. That's the quick introduction to where we are in Arbaflame right now, and I'm happy to take some questions. You're muted, Mark.
Thank you very much, Eric. Very interesting as such. There's a couple of questions in the chat, and I hope you can also answer them. One topic you mentioned, and I would highlight this. With the products from steam explosion and torrefaction, we are not addressing whitewood pellet market. We are not competing the industrial use, these 20 million tons of whitewood pellet for industrial use per year. We are addressing the 2 billion tons of steam coal that are consumed every year. And this also, and that's probably a message to the financial market, this is where our growth rate is and why we have such an enormous growth rate here. There is a couple of questions on pricing and also on overall costs and dust issues. If you would answer them, Eric, please, in the chat. Just as an overarching answer, those products we are discussing today are an ideal input for substitute and drop-in substitute for steam coal, because there's hardly any adjustment measurement needed at the consumer side. So there is no major investment on the power plant side, and this makes the big advantage. A little bit more capex in the processing saves you a lot of capex in the consumption, and this is the rationale behind the overall activity. And maybe that wasn't clear from the beginning, but this is why we are undertaking all of these activities in torrefaction and steam explosion. And by this, Eric, please have a look at the chat and at the questions, and I would pass on to Joris Spahn of Yilkins, another technologies provider, quite successful in implementing their technology by now around the globe. Very much looking forward to your presentation, Joris. I'm afraid you're muted if you're talking already.
No, I'm now. I hope you can see the presentation well. Thank you towards IBTC and also WBA for inviting Yilkins to have the opportunity to present our company as well, being one of the technology providers, giving clients an opportunity to decarbonize and to replace the steam coal, as it is mentioned. So what short presentation to introduce our technology and also look at different opportunities we see in the market. Myself, I'm Joris Spaan, the business development responsible for Yilkins, part of the team since 2015, and very well and likely to present you the next slides. A short step about Yilkins, the company itself. What we did from the beginning is that we focused on our core technology, and that is Torrefaction, of course. We do this from the Netherlands. We are a Dutch company located in a small place called Ruurlo in the Netherlands, close to the German border on the east side. The company was founded in 2015, but within the company we have at least more than 25 years of biomass conversion practice in our people and brains. If you look to the proposition we are offering to the market, as said, it is focusing on torrefaction, but also on drying, because with our swirling fluidized bed technology, we have a very well technology that can also do the drying very efficiently, that I will explain later on. These swirling fluidized bed is our own patent that we have. And what we do offer is that we offer our technology in modular skids. So the skids are being produced in the workshop in a nice environment and being shipped to the client finally to do the last step of assembly on site. And I think we are unique as technology provider that we also offering a performance warranty backstop insurance to the clients, of which we deliver a plan to. It was already mentioned and said, I think one of the most important parts of the torrefaction technology in general, and also from ours, is that you are capable of handling different type of feedstocks. I just show a glimpse of different feedstocks that are being processed in our demonstration plant that we're having in Ruurlo, and it's been in operation for the last 8 years. From the left side, you see forest residues, sawdust, straw, bagasse, also digestate, and also one of the last developments that we also published an article on lately in cooperation with Shell is using the organic waste fraction of municipality solid waste and torrefy these and produce nice pellets, as you can see on the right bottom side. So actually different type of feedstocks can be processed, can be torrefied, and can be densified at the end. A little bit background on our torrefaction technology itself. As you can see in this picture, on the left side, you see the blue part, the drying part. So as said, we do offer an integrated solution, including the drying step. And in the brownish part, you see the torrefaction step. Perhaps to start with the torrefaction. So after the process, after the feedstock is being dried to a moisture level below, let's say 10%, we start with the heating phase of the torrefaction. That is the first stage. You see the heating stage. So there we heat the material to the desired torrefaction temperature. As Michael explained, this differs from different feedstocks and is somewhere between the 250 to 320 degrees. After the material is being heated to the desired temperature, it goes to the next stage of torrefaction. We call it a torrefier. In this stage, the material gets time to devolatile and to create the product to the characteristics that the client wants to. So having this two-stage approach in torrefaction, we can play with both two process parameters that are available. So this is temperature on the first step and time in the second stage. By applying those different process conditions in a good way, you can make a very good homogeneous product. That is important. So no white spots left, totally torrefied. That is important. And you can do it with the highest efficiency. So not losing a lot of carbon in your process to the volatile gases that of course are coming out, but keep your carbon in the feedstock that finally goes to the client. As said, out of the torrefaction process, the volatile gases are being used in a combustor, and this combustor provides indirectly via heat exchangers the heat for drying and for the torrefaction stage as required. Perhaps it's good to mention that we can offer the both solutions also independently, because we do have a drying project that is going on with Heineken, for instance, to dry spent grains. And also we have delivered torrefaction plants to our clients that I will explain later on without drying. But we can also offer it integrated. Good thing to mention, because of the stack building that we're doing also for drying, we can build it on a very small footprint. So we can build in stack, in height, instead of doing it horizontal, and that can give a lot of advantages if you have to build something in a brownfield solution. Of course, the last stage, as mentioned, is important. To make a commodity product, you need to be able to densify the product very well. And one of the unique advantages having the Yilkins technology is that we are capable of controlling the torrefaction process in that way that we have enough material, lignin, and the product left over so that we can densify without using any additional binding agents. And this is an operational saving, of course, for the client. Last but not least, I think it's good to mention, Yilkins offers also an additional step to the torrefaction. So after pelleting, we can add an additional thermal treatment to the process to make a really hydrophobic pellet if required. So depending on the client wishes, we can also adapt to this step as well with our technology. I think it was mentioned also before. It's also good to have some, let's say, confidence and create some confidence to the market and our clients. How we did this in the past is having a lot of, underwent a lot of several successful due diligence processes, either with clients, but also with some insurance companies, because we do offer a performance warranty backstop insurance, as I mentioned. For instance, Markel, combined with New Energy Risk, did in due diligence on our technology, so to be able to offer this insurance to our clients. But of course, also we had due diligence done by DNV, but also a lot of different clients independently did their due diligence looking at our technology. Important to show this to the market that our process is efficient and reliable. I think it was mentioned before, and also by Michael. Of course, the main route, if you look from biomass to steam replacement or steam coal replacement, it's the power plants, of course. So I think the last 10-15 years, that was the main route if you look to biocoal, where it was used. And in this chain, you see from left to right, the biomass sources to the different applications, the material after torrefaction can be utilized, with some downstream technologies involved, of course. As mentioned, the route to power plants is the most common one, and also the one that was done also in the past. As Michael explained, I think already 15 years ago, also the predecessor of Yilkins already did a lot of co-firing tests in the Netherlands with RWE and Vattenfall successfully, up to more than 25% co-firing of biocoal in the plant. But now the world has changed a bit, and besides the route to power plants that is still applicable, especially Japan is very much looking into this area, and that's why we also sold a plant over there. But also the routes to green steel making and green fuels is of course very much into the picture today. Also there, if you wanted to go to green fuels, you need to look at gasification, and to be able to feed a gasifier, you should have biocoal products that is very grindable. Also for the steel route, we have a route, and I will show that later in the next slides that I want to present to you, to give examples of how the replacement of fossil steam coal can be done in these kind of routes. I think important to say before I go to the next slides that, as is shown here in the yellow block, Yilkins is focusing on its core technology. So that is torrefaction, and besides that also drying, of course, as explained. And to look to the other different applications like green steel, green fuels, we do work together with partners in the market. So we focus on our technology and we cooperate with different partners to look at different options and different applications and how to offer this to clients in the market. Same goes, by the way, for a total solution. Also, we as Yilkins can offer a total solution from biomass to the end product, but therefore also we have a partner that supports us from in this step. Okay, so to look to the next step, the green fuels, I just use an example. We do work together with ThyssenKrupp Uhde in Germany. We have a cooperation signed with them that Yilkins, as you can see, is doing the pre-treatment of the biomass and torrefy the material to make it very well grindable to be used in a gasifier as next step. With this gasifier, syngas is being produced. Syngas goes to the methanol plant, and with this methanol synthesis, the biomethanol can be produced. So this is an example of how today, let's say, fossil coals being used can be replaced by biocoal. The other example that I have is this one. In the route from biomass to liquids, Yilkins is working closely together with Shell. We have signed a cooperation agreement there as well. As I explained, we are focusing on our core technology, torrefaction, and we try to find partners in the market to offer total solutions to clients. As you can see in this route, the pre-treatment is done upfront. You need to pre-treat the biomass. As said, you need to torrefy it before creating a good product that is good millable, grindable to feed the gasifier with fine powder. After the gasifier, you need a Fischer-Tropsch process and hydro-wax process to convert the material finally in advanced biofuels. Also here you see a good example, a little bit more in detail here. Again, drying, torrefaction, milling, you create the solid fuel for the gasifier. It's already explained here in detail. Yeah, in this way, the torrefaction step creates finally a homogeneous product out of different varieties of feedstocks, like grasses, like woodies, like digestates, whatever what. Finally, you make a torrefied product out of it. And by milling, you make a fine powder and create a homogeneous feedstock that can be fed to the gasifier. This is needed because you need to feed the gasifier with a high density product. And in this way, you can replace the lignite, as Michael explained in the beginning of the presentation, but also the coal fed gasifiers that are in the world today. Another example of how the regular steam coal can be replaced by biocoal to make finally green fuels. Another step, and that is looking a little bit to the steel industry or the metallurgical industry, to be more clear. We also here, as said, we are focusing on our torrefaction and drying concepts. We work together here with Technored. Technored is a company that is looking to decarbonization routes for the steel industry and has a lot of knowledge on to the steel industry and the metallurgical industry, what the needs are to offer and drop in feed to that industry. If you look to the first three steps, what we are saying together with Technored, that you have to torrefy the material where the biomass is. So torrefy the biomass at its source. And after torrefying and agglomeration or densification it to the material to a black pellet, you bring the material to the steel plant, and then you do the carbonization step on site at the steel plant to make the desired product as the steel plant wants to have it. There you can mix it up with other materials, and make a drop-in fuel that can be used for coke ovens, for blast furnaces as well. So in this way, also here, biocoal can be a drop-in fuel, also having a route towards the steel industry and creating green steel products. Last but not least, to end with, it's not only theory, it's not only concepts, it's also practice. So what I want to show you here on the left side is the successful commissioning that we had beginning this year in Tokuyama, Yamaguchi in Japan. This client has installed a torrefaction plant on site with a capacity roughly 1 ton an hour to get hands-on experience with torrefaction, produce products, and do the milling and testing at their site. They are using palm residues from the palm industry as feedstock, and with this material they can produce a biocoal that is a substitute for the steam coal that they are using today. They are using roughly 1.5 million tons, so this is the first step of many plans to follow to replace the whole 1.5 million tons in total by 2035. On the right side, you see a torrefaction plant being installed from Yilkins at Reliance, Jamnagar in India. It's a large biorefinery site. They are using residues, agricultural residues as feedstock from India, of course. This feedstock is being torrefied. It's being offered as pre-dried material to our plant. So this is torrefaction only, what you see here. The material is being torrefied with a capacity of roughly 4 tons an hour. And this material is being used as replacement of the coal that they are using today in their gasifiers to produce all kind of chemical derivatives. So these are also, this plant is a first plant as a first step for many to follow for Reliance, because they have large ambitions, not only in replacing the coal for the existing coal for their gasifiers. That is one step. The second step that is also that they are looking to SAF and also biomethanol as next steps, where also biocoal can be used, of course, to make these sustainable products. Yeah, by this last slide, I think I gave you a glimpse of what is happening, what is Yilkins doing, what is Yilkins offering to the markets, and how we can support different companies in different industries to decarbonize. So, yeah, let's get in touch. If you have questions, let me know. And Michael, let me know if there are some questions that I need to answer right now.
Thank you very much, Joris, for this. And I noted in particular how much the people who have installed your plant were smiling when they were opening it. So obviously there is nice things going on with this plant. So very happy to see this. And
Thanks.
Probably before we switch to questions, there are a couple of questions that are around all kind of issues with product, but not on the technology itself. So permit me here to make one basic or general statement. I mean, with our technologies, we are upgrading biomass and we are substituting or aiming to substitute coal. All kind of issues that are along the coal train are literally also with our product. So if there is leaching issues with coal at an open coal yard, also our coal might have some requirement for treatment of leachate from the coal yards and similar. So this is really a drop-in product for steam coals, and therefore has some of the similar problems. We had also a couple of questions around feedstock flexibility. I think our speakers have addressed this very often and very clearly. Generally, all feedstock can be processed. It is just always the question, what are the requirements and the quality requirements from your clients? And these need to be bridged. So feedstock specification with client requirements. Literally garbage in, garbage out is a usual equation for an industrial process. Here we need to say if there is some very low quality biomass from the perspective of consumers, then as especially also Max pointed out here, pre-treatment might be necessary, and then the process chain will simply be a bit more complex. And this is typically a trade-off where you say, okay, my feedstock is getting cheaper, but I have a little bit higher processing costs to make these feedstocks accessible for the biocoal market. So there is a lot of trade-offs, and the torrefaction steam explosion is not the miracle technology that solves all the issues, but it contributes significantly to solve issues and to make tradable products that can really be dropped into existing cold chains. And therefore, this makes it very easily with these products now to succeed in the defossilization of many industries. Yeah, I don't know, is there any more questions left? Because there were a couple of questions also, if you would go to Africa, if there is already some activities outside Europe. I'm afraid we have had only presenters from Europe to date, but as we saw also in the presentations, they are not only active in Europe, so they are ready to go across out of these. And we see also that I have to admit that there is many non-European companies already in the field already, and also supplying technologies that might be also local technologies. Then please get in touch with us. We can direct you also at other members of ours with a track record that is worthwhile to be followed. But one thing, and this is probably, and with this I'm referring to a statement of the IBTC earlier. If you're entering now in project development and you're working with some of our technology supplying partners, please trust them in they define how the process should be set up, and they define the interfaces. Not you're taking the risk of the interfaces and saving a buck here and a buck there, but really let them design and calculate the whole process through. We have seen a couple of projects where the project developer was trying to save on the dryer or trying to save on the bucket conveyors or whatsoever, and precisely these interfaces and not matching chain elements in the machinery setup did then cause the projects and lead to economic chaos in the projects. That is a final statement from my side. Quickly, I don't know, let me pass through quickly. Max, would you also contribute with a final statement quickly at the same question, and to Erich and Joris? Couldn't, okay. Since Max seems to have an issue. Yeah.
Final statement. I would say the most important point in the future will be to secure feedstock, affordable feedstock, and yeah, control the entire value chain and having the right technology in place to also utilize potential side streams.
Thank you. Eric?
I think it's all about working closely together throughout the value chain and find optimal solutions together.
Thank you, Eric. And now, Joris, floor is yours quickly.
Thank you, Michael. Now, I think a lot of things were said already, but I would like to state out that, yes, please trust our companies to know where the battery limits are and to know how the interface should be solved. So that is one. And as said before, please work closely together and utilize the different knowledge in the value chain together. And then you create the best solutions with the client, to my belief.
Super. Thank you very much for these three very, very interesting presentations. Obviously, WBA will be then distributing and making accessible also the slide decks you have been seeing. Please feel free to address also the IBTC directly. I have shown your website, ibtc-council.org. Also feel free to download our dictionary of terms there. Yeah, I hope this was very interesting to you. As such, we'll really appreciate to have you with us in the second workshop of this series, which will be at the end of September, where we will then turn up the heat literally and increase carbonization degree, talking about biocarbon, talking about biochar and the ways and the pathways there too, as well as what kind of utilization we see outside of the power sector. Thank you very much for this, and to the World Biomass Association also, thank you very much for giving us this podium and allowing us to do all these presentations here. And please feel free to also continue on bilateral communication with the presenters and with the companies we have had here. Thank you very much on this, and bye-bye.
Thank you.